Now, I will now brief you through the program 6. I will now brief you through the program 6 of your CG labs. It says clip a line using Cohen-Sutherland algorithm. So first of all, we'll understand what is the Cohen-Sutherland algorithm, and then we will run through the program. So what is the basic concept here? So the Cohen-Sutherland algorithm uses a divide and conquer strategy. So the line segments endpoints are tested to see if the line can be trivially accepted or rejected. So we are talking in terms of your viewport, whether the line is present inside the viewport or not. So if the line cannot be trivially accepted or rejected, an intersection of the line with the window edge is determined, and the trivial reject accept test is then repeated. So we will understand this better with the help of an example. So this process is continued until the line is accepted. So to perform the trivial acceptance and rejection tests, we extend the edges of the window to divide the plane of the window into 9 regions. So each endpoint of the line segment is then assigned the code of the region in which it lies. So here, the each line endpoint is assigned a 4-bit region code. So this is how the region code is. So assuming, say for example, assuming this is this is your viewport. This is your viewport, and this is your window. Sorry, I'm sorry. This is the window, and this point is your viewport. So you are clipping and showing this particular. You want to clip and show a particular diagram that you have drawn on the viewport. Remember, we had done this when we were doing the second unit, which we did was clipping. So here, if this is the is this is the viewport, the complete window is divided basically into 9 regions. So by default, we take this as the region code. So the region code is basically done using a 4-bit code which is basically divided as ABRL. Now what is this ABRL? Each is 1 bit, where A stands for above, B stands for below, R stands for right, and L stands for left. Now let us understand what this means. So this is in reference to your viewport. So for a viewport, all these values RBL, as I told you, it is represented using a 4-bit region code. So this region code for the viewport is going to be 0. Now, depending on how the screen, how do you they assign the values for all the other parts on the screen. So for our reference, we divide the screen into 9 parts. So when we divide it into 9 parts, this is the center or the viewport region. So that is it is taking a 4-bit region. So toward now we will understand towards the top. So A, above the viewport region A is assigned as 1, and all the other bits are taken as 0. Now below the viewport region, it is below. So below is assigned as 1, and all the other remaining bits are taken as 0. Now again, coming to your left. So RBL, L stands for left. So here L is assigned the value 1. And R right, so R is in the third place. So the third bit is assigned to 1. So this is how you divide the screen first. First, it is divided into 4 parts. Now you have the corners to be also, the corners also need to be defined. The corners can be defined in two types. Either you can use an XOR operation, or simply again you can go back and I'd label them according to this. Say for example, I want to assign value to this region. Now if in accordance to the viewport, this region is on the top and it is to the left. So above and left. So top means above and left. So that's why I assign A with 1, left with 1, and the remaining as 0. Now coming to this part of the screen, it is above and to the right of the viewport. So above it takes 1, R takes 1, and the remaining bits take as 0. Coming back to this point here, it is below. it is below the viewport and it is to the right of the viewport. So again, what values are here? B and R take 1 and 1 each, the remaining is 0. So next, coming to this part, it is below and to the left. So B and L take 1 and 1, the remaining 2 bits, that is A and R, are going to take 0 and 0. So this is how we assign the screen. So why is this being done? So we want to check whether where the particular line that we want to clip, if it where does it lie in the window screen. Okay, so the left end point is set to end, as explained here, the end point left of the window is set to 1 bit, end point right of the window is set bit, second end point below end point is a third, and above is set to 4 here. So then, given the line segment with the endpoint, say for example, you have P1 and P2 is a line segment. It starts, this is the X1, Y1, and it starts from X2, Y2. So it will be explained better with the help of a diagram here. So this is the point that we are referring to here, as in the example, P1 and P2. So if you observe here, this is the viewport which we have drawn. Now, the entire line is not visible within the viewport. Only a partial line is visible within the viewport. So now this is the line that has to be drawn, and this part of the line has to be clipped. So how do we do it? First, we identified, again, like explained, we identify the viewport into, divide the viewport into 9 regions. So now we now try to take the code for we try to assign the code for each region. So for P1, the point, say for example, is lying within this region. So point P1 is assigned as 0000. So it is basically a no, 0. We are doing an AND operation. So for that, we will identify the region code for P1. Region code for P1 here is, since it is lying within the window, it's going to be 0000. Again, region code for P2 here, since it is above and on the top. So according to the region code here, it is going to be 1. P2 will be defined as 1. So it is above. So 1 0 0 0. Because it is at the center, we don't have any code for the center. All the remaining are taken as 0. So now we will and the two operations, that is 0000 ANDed with 1000. So you know that when you AND this operation, obviously you are going to get 1000. So when you have a non-zero value, that means to say that this point is outside. So here, this point has to be clipped. So again, we take the value here. Whenever you get a non-zero value after you AND it, that means to say that that portion has to be clipped. So we again find the value of, so we take this point as P dash 2, and then again we AND it with P1. So here for this point, it is going to be 0000. So ANDing 0000 of P1 and P dash 2000, we get a 000. So if it is a 0, that means to say that when you AND the operation, if you get the 4 bit as 0, that means to say that it is inside, the line is inside and no clipping is required. Likewise, you need to perform the same operation using AND operation. Identify the region in which these points lie, then perform the AND operation. So and then check whether the line is inside the region or outside the region. So remember, if you get all the when you AND 2 points, if you get 0, 4-bit zeros, that means to say that the line is inside and no clipping is required. So if you get a non-zero end value, that means to say that the line is outside, and again you have to compute checking on by clipping that line. So this is the basic concept of Cohen-Sutherland algorithm. So then basic commands that OpenGL commands that we will be using here is GL matrix mode. So what does it say? The GL matrix mode specifies which matrix is in the current matrix. So you can either have a GL model view, a projection view mode, or you can have is GL texture mode. Then we move to GL load identity. So what does this function do? It basically replaces the current matrix with the identity matrix. So it is semantically equivalent to calling the GL load matrix with an identity matrix. Then GLUT ortho 2D, it defines a 2D orthogonal projection matrix. Then we use a GL flush function. So the GL flush function empties all these buffers, causing all issued commands to be executed as quickly as they are accepted by the actual rendering of the engine. So then finally we use one more function here, GL color 3F. So this can be called, as we have learned, it is called between the GL begin and the end function. So it is the way which it is basically used to give color to each vertex that we are trying to highlight. So we know that you have three colors RGB. So whichever color you want to highlight, that takes the value 1. The remaining, it takes the value as 0. Now let me quickly run through uh, the program that you have to write here. So this is the program that we are talking about, Cohen-Sutherland line clipping algorithm. As explained, first of all, you would be setting the window, or this is your X max, Y max. This would be your window settings, and this would be your viewport settings. Then again, we are computing to check. So the compute out code basically compute out code is a function to identify the neighbors of the region code. That is whether it is A above or below or right or towards the left. So this is where the actual line clipping takes place. It retrieves the value from the compute code, whether the 4-bit code is retrieved here, and the 4-bit code is retrieved here, and then for the 2 points that we are taking into consideration, and operation is performed. So after performing the and operation, it will check whether the value that is got is 0. So if it has got 4-bit 0, then it will assume that no clipping is done. So if it doesn't get a 4-bit 0, then it makes sure that clipping is done. So these are your OpenGL commands, which basically trying to give the values of the points. You are basically defining the lines here, 50, 50, 100, 100. This is the first line, second line, third line, and the fourth line. This is how your lines are drawn. So starting of the first line and ending of the first line, starting of the second line and ending of the second line. So you have defined the points here, and you have highlighted which color is in which these lines have to be displayed. So this basically is your a way in which the line is drawn. Initially, the line is drawn. Then after the clipping takes place, it will come to the void display. Here, the clipped image of the function is what is going to be displayed here. All this is included in your main function. You call the main function, and finally, you will get the clipped image of the diagram. So the output here is this is how you execute the program. G++ lab, that is I have named it as lab5.cpp, that is LGLU hyphen LGL small l glut, then a output. So this is how your output is going to be. So this is your initial 2 lines that you have drawn, and this is the area of clipping that you have defined. After it is clipped, this is how the program is going to look. So this completes your first program, that is fifth program, that is Cohen-Sutherland line algorithm. Thank you.